Okay. Okay, before we proceed with more examples on graphical convolution, let us review exercise 1B. I notice only a few of you submitted the exercise on the Padlet. So let us all look again, and then we discuss more on different type of examples. Okay, so let me choose, because last time we discussed on the one with the same I think 1A, about the same height, only the difference is the width. Now let us look a different one, and then I think with this you can proceed with 1C. Okay. Okay, now that we have two signals, okay, one with time with amplitude 2 and the time is 4 seconds. Another one is amplitude 1, I think, with a time is 2 seconds. So remember that the step for graphical convolutions, we have to change the t to tau, and then one of the signals has to be flipped and shifted. Okay, for example, let us use the smaller one to be the one that has to go through the shifting and flipping. So this the bigger one remains here, the xt. Let us name it as xt. So we have xt 2 to 4 seconds, and then our ht minus tau will be the smaller square. Kalau kita tengok balik semula the question, mana question saya ni? Oops. Okay, this one. So A, the punya amplitude is 2 and T dia adalah 4, and then another one is 1 amplitude but the T is 2 seconds. So this is for 1B. So we're going to do the convolutions, meaning that the HT minus tau will go through the process of moving from left to right. So if we can imagine, there are about five cases. One where the two signals do not overlap, and then start to overlap, and then fully overlap, and then start to leave the one that stayed, and finally no overlap. Jadi kalau kita lihat di sini, I can show you this. This is the Jamboard. Okay, so we're going to have about 5 parts when we want to do the convolution. We will look one by one. One is when the HT minus tau will be the blue one, and then the bigger one is X tau. So this is when kita dah tukarkanlah kepada T to tau, and then one is flipping and shifting. Again, YT and T minus 2. T ni anywhere along this X-axis, and T minus 2 because dia punya lebar. And then kenapa ke kanan? Because of the T is plus. Okay, so when they do not overlap, because the value for Y is convolve kita multiply, basically integral and multiply. So bila sini ada signal, but the signal for the other one, the bigger one, tak ada 0. So anything times 0 will be 0. So when there is no overlap, the YT is 0. Okay, case 2, when the H start to approach yang bigger one. So bigger one ni tadi 2 dengan 4, 2 and 4. Whereas the smaller one, the amplitude is 1 with the width is 2. So first, let us look, bila dia start masuk kepada, this is when T less than 0. Okay, so bila T dia after 0, okay, T more than 0, and then until dia terus habis ke sini. Kalau kita lihat, if you look here, this is when dia masuk dah dalam region ni, and then dia teruskan until dia about T ni dah approach ke 0 kan. Okay, so T0, bila T0, T yang hujung ni 0, T this one will be 2. Okay, so bila this one 0, okay, bila di sini 0, yang ini akan dapat 2. So between T between 0 to 2, kita dapati our overlapping will be between T to 0. Sama sini, T to 0. Notice that the area from smaller to bigger. Okay, jadi kita boleh expect YT dia akan naik. Okay, so how to define, how to calculate the YT? Okay, so look at this notes. YT from 0 to T, sebab kita nak cari overlapping, will be, overlapping ni adalah this blue one times the black one. So the blue one is 1, the black one is 2, d tau. So bila kita integrate 2 tau for 0 to T, kenapa 0 to T? Yang ni lah, the shaded one is between 0 to T. And then we have 2T. Okay, jadi kalau kita nak buat tu from 0 to 2, okay, dia adalah graph T with dia punya, apa dia panggil, gradient is 2. Jadi kalau 2 tu bermakna sini berapa kelas? Dia punya Y, kalau gradient 2, ini will be around 4 lah. Okay, sebab gradient kita 2. 4 divided by 2. Okay, so we have here YT equals 2T. Okay, so this one. Bagaimana dapat dia? Beginilah. Dia tinggi, dia besar until the T approaching 2. That will be the third case. Okay, the third case, we have this one, 4 and 2. Hilap. Apa tadi? 2 dengan 4. Okay. This one is 2. This one is 4. And then the blue one will start ni. Okay, the blue one will start to overlap. And then di sini 0, kita kata tadi dia 2. Okay, and then dia akan, let's say kita bergerakkan dia ke 3 1 and 3. Oops, silap color. Just to show you the movement, sebab kalau you nak understand more on the how we get this, you can look at the one that I showed you, the motion GIF file tu Okay, so kat sini lah, dan dia akan bergerak sehingga, let's say saya buat sampai 4 tu lah So this one up until 4. Kalau sini 4 makna salah kada pula. Okay. Okay, sekejap. Susah. It's very difficult for me to write this one. Pakai mouse. Okay, let's say 4. Sebelum dia leave Then this is the blue one. Sebelum dia leave lah. So kalau this one 4, makna di sini 2. Okay. So we can understand, kita boleh nampak di sini bila masa dia will be fully overlap for the two signals. Okay, so how are we going to find uh, the value? Okay, so these two functions overlap for between, kalau kita tengok between bila t, this one ni sebenarnya adalah t, t, yang ni is t minus 2. So T start to overlap 2 and then dia pergi lagi, yang ni sebab T ni depan T depan, until dia 4. Dia approach 4. Okay. So the two functions fully overlap. So between T to T minus 2, okay, dia punya range is between 2 to 4, this one. Okay, sebab sebelum tadi 0 to 2 dia only partial overlap So from 2 to 4, it will be fully overlap. Okay, so bila kita nak buat sini fully overlap, so the T is from T to T minus 2 lah, this T. To T minus 2. Okay, and then the value is 1 and 2 here, 1 and 2 d tau. So 2 tau, now we have the value is 4. Jadi sebab dia punya area, total area overlap always the same. This blue one which is 4 lah. Okay, jadi kalau kita balik pada tadi, so 4 between 2 to 4. Okay, and then for case number 4, okay, case number 4 when the small square start to leave. Okay, kalau kita lihat dekat sini, when we want to draw, okay, jadi dia dah keluar sikit, dia ini, ataupun mungkin dia tinggal sikit je. Kita let us imagine how these two signals going away to from the bigger square. Jadi kalau kita lihat for the limits, because as I mentioned earlier, this is between 4. Macam mana kita nak tahu dia daripada mana ke mana because kalau kita lihat di sini finally ni, dia sikit je lagi, macam itulah. So this one is 4, since this is 2, so this one will be 6. Okay, so the T will be between 4 to 6. Okay, what about the area of overlapping? The area of overlapping will be, so kalau kita tengok sini 0, this is T, this is 4, this is T minus 2, T minus 2, this is 4, and this is T. Okay, so area overlapping will be between 4 to T minus 2, and then this still lagi overlap, yang area yang di overlap adalah 2 times 1. Okay, the same as previously, but the change is only on the limit. And then bila kita gantikan the value macam biasa integration, so I don't have to explain that. So we have about 12 minus 2t. Okay, so yt kita akan dapat 12 minus 2t, and then if you continue this is what we have lah. Dia minus kan. Okay, tak muat 6. Okay, this one tadi adalah 2t. This one is 12 minus 2t. Okay, boleh kelas?
Boleh doktor.
Okey, boleh lebih kurang kita dapat sebab saya tengok tak ramai yang hantar. So these are the answers lah. So from t less than 0, t between 0 to 2, t between 2 to 4, t between 4 to 6, and finally t above 6. Because kalau kita, if you look here, after that there will be no, sebab ni t ni t, this one t minus 2. T lepas daripada 6 dia dah tak ada, no more overlapping, so it will be 0. So this is how our YT looks like. Okay, I just put the part 2. So today, jadi untuk before the first on Monday, we learn about when two square signals overlap with the same dimension. And then hari ni kita tengok dia punya dimension berubah sedikit so that you understand how the convolution process is lah. So I will proceed today with hari ni punya examples adalah on square dan juga, bukan square lah, unit unit function with sawtooth ataupun segitiga, and then we also look kalau sempat on nanti juga unit with exponential. Okay. So again, this is the steps for convolution. Sketch the two signals, replace t to tau, and then pilih salah satu signal to be flipped and shifted. Okay. So kali ni saya akan tunjukkan dua because the next example will be on saya cakap tadi unit step dengan sawtooth. Jadi kita try tengok one of the signals, kita tukarkan dia lah. Nanti saya akan cerita kat sini bagaimana bila satu bertukar dan satu lagi maintain. Okay, jadi this is the signal, this is the original signals. So let's say the sawtooth is GT, okay, and another one is UT. Okay, again saya revise balik semula. So kita kalau masih ingat masa chapter 1 we learn about unit functions. Kita ada RAM. Okay, RAM usually kita refer sebagai RT, and then kita ada this is step. Jadi ni kena sentiasa ingat ni sebab step ni kita banyak kali pakai. So step ni this is actually the signal for step, UT. So bila kita kata UT ni dia maksudnya lepas 0 the value is 1. But then let's say I have UT minus dengan UT minus 4 for example. So boleh imagine signal dia macam mana kelas? How will the signal look like? So minus dengan satu lagi signal. Ni dia shifted ke kiri ke kanan kalau minus 4. Hello?
Ke kanan.
Kanan. Okay, so sini 4 So ini unit step. Ini yang 2t minus 1. Jadi kalau kita ada signal yang begini, let's say this is my signal for X lah. So macam mana bentuk saya? XT UT minus ni. So yang tinggal hanya sehingga 4, 1 Boleh
Boleh doktor.
Okay, so kali ni kita tak ada tolak-tolak. We only have this unit functions and sawtooth. Okay, let's say dia kata kat sini UT equal to 1, GT ni macam RAM lah tapi kita hanya tengok sehingga 1 sahaja. So we want to convolve GT and UT. Okay, let's say method 1 saya pilih GT yang akan di flip and shift. Okay, so ni kita punya UT, kita punya GT tadi kita tukarkan kepada tau sebab dia tadi kalau tengok sini Okay, so when I shifted flip and shift, so my G T minus tau will be, satu dia flip, and then dia shift lah katakan sebanyak T. Okay, shift lah sebanyak T, sebelah sini positif, kena belah kiri, and then since dia punya lebar adalah 1, this one will be T minus 1. So part ni semua faham sebab yang ini yang paling penting. Kalau shift dengan flip ni you tak faham, sebab kita belajar time transformation, shift, lift dengan scaling. Kalau that one kita tak faham tu susah lah. Overly you faham Okay, and then when we want to convolve, ni semua step, so kita dah buat dah, kita tukar, kita flip, and now we want to do the convolution, convolve. So YT now will be integral of UT, U ke X tadi dia cakap? UT X kot. T G T minus tau Okay, so the same as before, kita akan dapati ada beberapa case. First case will be less than 0, and then they're approaching, and then dia akan fully overlap. Since kita punya signal U ni adalah unit function, so dia tak habis lah sehingga more than certain value ataupun sehingga infinity. So let us look one by one the case. So case 1, when T less than 0 lah. Okay, T less than 0. So kita dapati T less than 0, saya letakkan my signals color biru lagi. So here lah. Okay. So T minus 1. Okay, so our YT will be 0. Tak ada overlap. Okay, again case 2 bila triangular ni. Okay, sebelum tu silap saya, yang ni first step saya pakai triangular. Sekejap. Method 1 saya pakai, yes, triangular. Triangular ni bila kita saya tak mention sebelum ni okay, tak ada. Before this sebab bila kita nak masukkan when we want to put the integration, nanti kita kena letak value kan, because bila integration this is xt dengan ht minus tau so this is yang kita overlap adalah this one this signal rt tadi, ataupun kita panggil dia tadi gt, and then we know that this gt is actually the ramp. Okay, t. Okay, so this is GT and T. Tapi bila kita flip dia, okay, so this GT minus tau, saya bawa ke sini supaya nampak sikit. GT minus tau, sebab every apa yang T tu kita tukar kepada T minus tau. So now our signal, okay, adalah T minus tau instead of tadi T Yang ni tadi asal, I put it red lah. So asal yang ini. So now dia punya equation adalah T tapi dalam ni dalam ni saya buat lambda. Okay, tak apa lambda dengan tau tu sama tau. Okay. So kena bear in mind ni, kalau kita pakai segitiga sebagai yang the one that going to be shifted and lifted. Shift and flip, sorry. Okay. Kalau macam tadi, contoh-contoh sebelum ni tadi, dia adalah a constant value. So it doesn't mean anything lah, because bila T pun dia value yang sama Tetapi di sini, bila we have the ramp, because the ramp is T, so dia punya function pun will always change T to tau. Okay, so kita bayangkan dulu dia punya signal bila dia start approaching. So we have one is the unit function, unit sampai infinity, and then another one is the yang ini Kalau kita tengok dia punya limit dia will be 0 to t lah. Okay. So untuk mendapatkan value, to find the value y t, kita tahu equation dia is integration. So integration di sini is 2 to t based on this overlap figure. And then the function is ut ataupun xt times gt minus tau. So ut forever 1. And then our gt minus tau is t minus t pergi buat tau sekejap t minus tau. And then dt. Okay. So bila saya tukarkan equal t bila kita t lah t macam t is sort of like a constant. So bila kita ditaukan dia, integral kan t tau. So it will be t tau minus tau ni bila kita integralkan will be tau square over 2. And then the tau will be between 0 to t. Okay, 0 ni 0 lah. So that's why we have t square. Okay, ni dah asal t. Tau ni jadi t, dapat t square. And then tau square dapat t square over 2. So that is why we have t square over 2. Okay, this is case 2. And then when we go to case 3, ni tak payah sampai 5 lah sebab dia forever infinity yang unit tu So the unit will be forever, sama je. And then after, kalau kita tengok tadi, dia partial tu until t equal to 1. Kan sebab lebar dia 1 tadi. Jadi bila dia start 1, bila dia dah sampai 1 kalau kita tengok kat sini. Bila dia dah sampai 1 tu, dia akan fully. Tadi saya buat warna apa? Sama biru. Bila dia masuk sikit sehingga yang hujung dia tadi tu. Okay, this one. Minus 1 G. Dia fully, sampai bila dia gerak pun dia akan sentiasa fully. So only 3 cases lah dalam case ni. Sebab kalau sebelum-sebelum ni dia putus kan So for these cases, it is when t more than 1. More or equal to 1. Kalau kita tengok kat sini, bila dia more or equal to 1, jadi dia akan sentiasa fully overlap. Oh, saya buat value dia tak sama, sorry. Dia sama panjang tadi kan, 1 and 1 Okay, so to get the value of y dia will always be from t to t minus 1. Okay, t minus 1 to t. Sebab kita tengok based on this the overlapping diagram ni. And then again dia sentiasa the same signal which is unit times yang blue tadi apa signal dia? T minus tau. And then d tau. Sama je tadi, kita dah buat tadi. T dapat t tau. Tolak dengan, silap. Saya tak pakai lambda, aduh. Tadi kita dapat ni t tau tolak tau squared minus tau squared over 2. So t tau minus tau square over 2. The only difference is the limit. So this one will be t minus 1 to t. Jadi kalau kita tengok sebelum-sebelum ni pun the example for this one, for example, bila kita buat integration, it will always be the same function because dia adalah xt and ht minus tau. The only difference is dia punya limit. Okay, sama juga macam ni lah. It will always be this one. But the only difference is limit. Macam ni tadi 0 to t. Okay. Yang ni adalah t minus 1 to t. So that is why you have to be very careful when you want to do the integration. Jadi selalu refer balik pada diseraja yang overlapping diagram. Okay, so when we put the value of t here, so the value will be 1/2. Jadi untuk this one, yt will be 1/2. Okay, so go back. Mula-mula 0 and then we sort of having a quadratic function kat sini, t square over 2. Okay, salah satu cara macam mana kita nak plot will be by putting that into the Excel file lah. Ataupun kita boleh expect dia adalah macam ini, exponential gitu So when we want to draw, so between 0, boleh tengok tadi 0, dia 0, and then dia t square over 2 from 0 to 1, and then kalau kita tukarkan 1, it will be 1 kat sini, kat sini akan jadi 1 over 2 lah. Okay, so this is y. Jadi dia lebih kurang macam ini lah. And then afterwards, more than 1, there will always be half. So signal kita lebih kurang macam ini. Okay. Okay ni. So this is method 1. Method 2 is when kita tak nak buat yang kita pun the sawtooth as the one that going to be shifted and lifted. So the one that we are going to leave is kita punya unit function. Okay, so kalau macam gitu, refer balik tadi signal kita. Okay, so we have a unit function. So we have yang ni kita maintain, yang ni kita tak nak shift, kita biarkan dia. Seperti tu. The one that we going to shift and lifted will be yang inilah. So this one yang saya akan tukarkan blue. So bila kita shift dia jadi sebelah sana. And then dia macam inilah lebih kurang So we have T. So this one will be U sebab dia tak ada limit lah. Macam ni tadi dia ada limit lebar dia So this one will lambda sahajalah So this will be T. Okay. Jadi kalau kita tengok dekat sini, so the first one sama je, tak ada overlap. So the YT will be 0. And then when the unit functions ni, dia start approaching the sawtooth, so dia ada overlapping di situ. So the overlapping limit will be between T to 0. Okay, jadi kat sini saya nak highlight since the one that we overlap adalah yang ini, which is 1. Jadi bila unit constant value, bila dia go through shifting and lifting, dia sama. Kita ambil sama juga 1. And then kalau perhatikan di sini, we maintain this G as kat sini lambda lah, ataupun saya buat tadi tau tau. Kalau sebelum ni tadi, dia menjadi T minus tau. So please be careful with this lah. If we have a triangular ataupun ramp function which has a variable of T, jadi kita kena follow dia jadi T minus tau. Katakan ataupun ramp function kita 2T ke, jadi kat sini will be 2T minus tau Lebih kalau kat sini kita maintain, dia tetap T. Okay, so bila case 2 tu, so T between 0 to, ini lebar dia 1 kan. Okay, dia punya YT will be sama juga bila dia pergi tu, bila dia approach, color lain lah, hijau, approach ni, so this one will be T lah. And then T sama 0 to T, tetapi sini kita punya function satu ni adalah 1, another one would only be tau sahaja. Okay, d tau. So it will be tau square over 2 lah. Okay, tau square over 2. T tau, dah siap-siap tukar. Tau. So for 0 to T, kita dapat T square over 2. Okay. Then for bila case ketiga more than 1, so this is what happen. So sama juga, kita dapat half juga. Okay. Case 3, YT dia half. So bila kita plot, samalah. Okay. Okay kelas? The highlight here kat sini saya nak tunjukkan when you use which function that you want to flip and shifted tu. Jadi dalam case ini, apabila segitiga, jadi kena make sure the equation for that functions also will be shifted and lifted. Sini lah dia kena ikut equation ni ya. Okay. So kalau tak ada soalan, saya teruskan. Ada soalan? Kelas? Okay so far?
Okey, Doktor.
Seorang je respon. Saya ni student macam seorang je kat sini. Seorang, dua orang je respon. Yang lain, where are you class? Okay, thank you Lim. At least Lim message. Yang lain senyap ni saya tak tahu lah dia tidur ke kan? Kan kalau ada
Ada
dalam,
doktor.
Okey doktor.
okay. Kan ada dalam apa? Dalam Facebook tu, ada tidur kan? Rupanya dia letak gambar video. Real lah lecturer dia ingat dia dengar Okay, so let us another one common examples will be, so saya bagi kat sini exercise, please try. Ini ke? Okay, this is example for unit dengan juga sotus ataupun RAM lah. So try. Based on the notes, it says that the answer is here. So you all try lah Okay, kita tengok the last one. The last one is between the pulse and exponential. Okay, let's say exponential kita, dia punya value here is alpha. Alpha tu any value lah, 2 ke 3 ke 4 ke. So if you can still remember, exponential kita ada decay ataupun satu decay, yang ni kita panggil decay lah. Satu lagi dia menaik situ That one depends on the dia punya time function di sini. So in our case for this one, saya punya jemput tadi hilang lah. Okay, sekarang kita punya signal adalah yang ini, is value of alpha exponential, sebab dia punya E adalah minus So let's say this one is H yang kita tak gerakkan, so kita maintain dia sebagai alpha E minus because decay, kat sini dia pakai apa? Beta beta T, so jadi tau lah. Okay, and the one that shifted and lifted is the unit function. So unit function ni yang lagi senang lah. Usually kita pilih dia, this is T, yang ni jadi T minus 1 lah lebar dia Kalau unit je kena ingat lah selalu mesti T minus 1. kalau unit pulse sebenarnya ni. Okay, so same like before, we going to have cases. Jadi kat sini sebab dia juga adalah infinity macam case yang tadi, so dia hanya ada 3 case. Okay, kalau dia macam putus ada break tu, kita kena tengok juga ketika dia living tu ada So I just show it from the slide. Okay, this one t minus 1. Okay, yang ni maintain alpha. So there will be 3 cases, 3 parts sama macam yang previous examples. So when it does not overlap, so yt dia 0. Okay, and then bila dia start overlap sini, so kalau kita lihat t to 0, limit dia ni kena perhatikan t to 0 until dia akan fully overlap bila t ni ikut t minus 1 to 0. T minus 1 equal to 0 lah. Yang case bila dia fully tu, bila t ni, t minus 1 ni equal to 0, yang ni bila t minus 1 equal to 0, yang ni jadi 1. Okay. Dia akan sentiasa overlap even though yang ni mengurang walaupun dia start to decay, but then the functions always be the same. So for this one, function dia adalah 1 times with the ht is alpha e minus beta tau, exponential minus beta tau di tau. So bila kita buat integration, Allah tak ada limit pula sini Okay, so case ada je saya tertinggal Case 2, case 1. So yt should be 0 to t. Kenapa sini? Yang ni tadi lah. Mana dia tadi? Ni. Oh, yang ni dah ada lah sini. Okay, overlap t to 0 So t to 0, so yang ni 1 times alpha e minus beta tau d tau. So bawa ke bawah sini, so it will be minus beta e minus beta zero to t. Oh, dia tak muat. Okay, so ni saya tertinggal ni So bila kita kira, because this one saya dah dapat jawapan terus. Okay, so bila kita gantikan dia, because e to the power of 0 is 1 minus, dia sepatutnya minus, dia patah balik, dia bawa situ. So kita akan dapat this equation, and then for t over, because it always overlap, tinggal lagi degree dia overlap, the amount of overlapping will be reduced lah. Okay, so to calculate the y, so sekarang ni macam mana kita nak tahu limit, because it always between t to t minus 1. Okay, so kalau kita gantikan value, we will get this one. But then I think something wrong with this value. So tolong double check sebab ni saya copy saja daripada buku Navi tu. So, but then bila saya try, kita letak value dia tak dapat. So maybe this one so saya tukarkan alpha beta e minus beta, because minus beta kita bawa sini. So e minus beta t minus e minus beta, this one t minus 1 Okay, saya rasa yang ni betul, this part. Nanti you all double check, tukarkan. Okay. So this is for exponential. Ada soalan? Kelas?
Tiada doktor.
Dia ada dah mengantuk ke lapar? So, kalau kita tengok.
Okey dah tak okey.
Ha?
Saya
Okey.
okey.
Okey tak okey? T minus 1 dengan T alpha E minus beta tau D tau. So ni bawa ke bawah, saya akan dapat alpha over minus beta T minus beta tau T minus 1 to T. Bila saya masukkan minus beta T minus E minus beta T dengan E minus beta lah. Okay. So susun-susunkan, this is what you have lah. Tapi kat sini ni saya tak sure ni betul ke tak ni. So, sudah bercheck Okay, so this is for between unit step again with exponential. Sebelum tadi adalah unit step with triangular ataupun RAM. So as an exercise, why do we have to do this convolution and so forth? So this is an example in terms of a circuit. So let's say, let us look here for the RL circuit shown. Use the convolution integral to find the response IOT. So IOT ni adalah output current here. So let's say we have a parallel R and L circuit. So kita ada current source di sini. So we have a parallel R and L. And then from the circuit KCL punya equations, so we have the equation for I naught. I naught is IS times HT. So IS adalah dalam bentuk square. Sini IS is the source, which is a unit lah, unit step function. And then the H is the decaying function. Maknanya dia makin kurang decay. Okay, kalau if I have this signal class, kalau saya nak buat dalam bentuk